Alright, so we're looking at lesson 19 today. We're going to look at constant acceleration. So hopefully after this lesson you'll understand how constant acceleration works. The motion equation for objects that have a constant acceleration is found from this equation. So I would write this one down, and I've defined all your variables. V of t is just the velocity at time t. V sub 0 is the velocity at time 0. A is your acceleration, constant acceleration, and then t is your time. So y'all want to add that to your formula sheet. If you have an object that has an initial velocity of v sub o, it will move a distance of v sub ot during that time. And the distance is just represented by the area of the rectangle. The distance is your y value times your x value, which is your v sub o times your t value. If you have an object at rest when time equals 0 and it accelerates at a constant rate, then the distance the object travels is represented by the area of a triangle, because it looks like a triangle here. 1/2 t times at gives you the 1/2 at squared. Your total displacement of your object from your initial point just equals the change in position due to your initial velocity plus the position change due to the constant acceleration. And that's given by this formula, so you may want to write it down. So the change in x means the change in your position. V sub o is velocity at time 0, t is time, and then 1/2 a is acceleration, and t again is time. So that's your displacement equation that you probably want to add to your formula sheet. So we're going to look at an example here. The initial position of an object was at the origin. Its initial velocity was 30 meters per second, and its acceleration was a constant negative 5 meters per second. What was its velocity after 10 seconds, and what was its position? So we're going to use our two formulas that we were just looking at. So for velocity, that's the formula you're going to use. So it wants to know what is the velocity after 10 seconds. Well, our initial velocity was 30. Our acceleration was -5, and it says after 10 seconds. So 30 minus 50 is -20. And we only have one sig fig in our problem, so we only have one sig fig here. So -20, and then velocity is meters per second. Okay, for the position, we're going to use that formula there. And so the change in your position our initial velocity was 30, and our time is 10. Our acceleration is -5, and again our time is 10. So if you multiply here, we have 300 plus 1/2 times -500. So 300 plus -250. So 50. And it started at the origin, and so origin is 0, so the change in position was 50, so its position was 50, and units for that are meters. So that would be your answer for your position. So that's how you can use those two formulas. They're not terribly difficult, you just have to know what to do with them. Okay, we're going to look at another one. A car with an initial velocity of 30 meters per second began to accelerate at a constant rate of 2.8 meters per second. How long does it take the car to travel a distance of 200? And then what will be the velocity when the car has traveled 200? So we're going to set up both of our equations. Our velocity is that one, and our position is that equation. So if you're not sure what to do, the best thing is just to start with both of them and see where you can go. So we know our initial velocity was 30, and the acceleration is 2.8, and we don't know our time. Over here, we know the change in position was 200, because it says it wants to travel a distance of 200. The velocity initially was 300. We don't know the t, and then our acceleration was 2.8, and again we don't know t. Okay, so we're going to have to figure out our t first before we can figure out our velocity. So I'm going to set this up so that I have 1/2 times 2.8, which is 1.4 t squared, and then plus 30t, and then minus 200. And then from here I can use the quadratic formula, and that's going to solve for t. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So if you don't know the quadratic formula, you do want to learn it. You will use it throughout the year. Hopefully you already know it though. Alright, so now use your calculator to get your t. So you should get two different t values. One of them is negative. It is an answer to the quadratic equation, but time is not negative. So our time is going to be 5.337. And we have 2 sig figs for the 30 and the 2.8, so that's how many sig figs we're going to have. So we're going to have 5.3 seconds for how long it takes to travel 200 meters. For now we have to find the velocity when it had traveled 200 meters. So we're just going to plug that into our equation. So 30 plus 2.8 times 5.337. And so you should get 44.94. And we again want 2 sig figs, so that would be 45 and then meters per second. So that would be your answer for the velocity there. Okay, we're going to look at one more example. We have a truck traveling 29 meters per second. Because of an obstruction on the road, it's forced to stop. If the truck can decelerate at a constant 4.58 meters per second, how long will it take to stop, and how far does it travel before it stops? So again, we're going to set up our two equations and see what we can fill in. So our velocity equation and our position equation. And you may learn them just because you write them so often. You don't have to memorize them, but they may just be something you learn just because of how often you write it. So our initial velocity is 29, and our acceleration is negative 4.58 because it's decelerating, it's slowing down. And then we don't know our time. It says how long will it take? We're not sure. And then over here, we don't know the change in x. Our initial velocity is 29. We don't know our time. We know our acceleration is negative 4.58 and our t squared. So there's something else that we have to know because neither one of these equations currently is solvable. It says the truck can decelerate. How long will it take to stop? So when it stops, what is the velocity? It's not going to be moving any longer. So that means that our velocity when we end at this time is going to be 0. And so now we can solve this equation for t. They're never going to give you an equation that is unsolvable. You always have to go back to the problem and look at your information and see what you missed the first time. So if you solve for your t, you should get 6.3318. And we have 3 sig figs, so we're going to have 6.33 for your time. And then we're going to plug that into this formula. And again, make sure you're using the whole number on your calculator, not just the 6.33. And if you use your calculator, you should get the change in position is 91.8 meters, and it says how far does it travel. It doesn't tell us anything about where it started, so all we know is that it traveled that distance. So that would be your answer for part B. So that's how you use those equations. So hopefully that helps you with those equations. Your homework is 1 through 20 and the curveball questions, so make sure that you do those so we can go over your questions tomorrow.